So we'll start with that HSC problem, and the first thing we have to do is work out the force on the electron. Now we know that electric field is force per unit of charge, so force is E times Q, and E we're not given, but we're given voltage and distance, so we have 100 volts over 0.1 meters, which gives us 1,000 volts per meter. So then we can have F equals Q, which is 1.6 by 10 to the minus 19 times 1,000. We have 1.6, 2 decimal places I think is all we need here, by 10 to the minus 16 newtons, and it will be directed towards the 0 volt plate. So the next thing we need, if we're to treat this as a projectile, we need to know the acceleration, which is force over mass, just Newton's law there. So we have 1.6 by 10 to the minus 16 over 9.109 by 10 to the minus 31 kilograms, which gives us 1.757 by 10 to the 14 meters per second squared. And we always keep a couple of extra significant figures right until the end. Now it comes in at an angle of 60, and the speed is 6 by 10 to the 6 meters per second, but we only really want the vertical component of that, which will be 5.2 by 10 to the 6 meters per second. So we know that U, the initial speed there, 5.2 by 10 to the 6. A, in the negative direction, 1.757 by 10 to the 14. We know by the time it reaches the bottom, there are two ways to do it. Either you work out the time to go to its maximum height and then you double it, or you use the symmetry and the fact that it is, since it's a symmetric situation, its speed as it hits the bottom plate will be the negative of the speed at the beginning. So I will use that one, and I'm going to use V equals U plus AT. So since V is minus 5.2 by 10 to the 6, we have minus 5.2 by 10 to the 6 equals 5.2 by 10 to the 6 minus A, because adding A, but A is a negative, so 1.757 by 10 to the 14 times T. When we work that out for T, we get that T is 5.9 by 10 to the minus 8 seconds, or we can write it as 59 nanoseconds. So the solutions for the quiz questions at the end of lesson 2.2. Just to start with number 1, we've got E naught is V over D, but the new electric field is V over 4D, so it'll be a quarter the original field, so that's C. Number 2, we have D is 0.2 meters, delta V equals 75 volts, E equals V over D, 75 over 0.2, 375 volts per meter, which is D. 3, we have 3 different sets of plates, equal distance. We have plus 50 to plus 250, which gives us a potential difference of 200. We have minus 100 to plus 150, which gives us 250 volts potential difference, and minus 250 to plus 50 gives us 300 volts potential difference. So we have VC is bigger than VB is bigger than VA. So since their separation's the same, the electric fields go in the same way. So we have C is our answer there. So question 4. Now remember that if we have a graph of potential versus distance, then the electric field, that is potential over distance, is going to be the gradient. So for part AB of the line, it's just horizontal, so the gradient is going to be 0. So electric field is 0 there. Now BC, the gradient, we'll just use our equation y2 minus y1 over x2 minus x1, and they have said that they only want the magnitude of the electric field, which means we don't have to think about the signs. So we just have the change in potential, meaning the rise over the run, which is that distance there. So we have 2 over 0.2 gives us 10 volts per meter. And for the part CD, the gradient on the same basis, it's now 3 minus 1 over 0.8 minus 0.4. So that again is 2 over 0.4, and that is 5 volts per meter. Now question 5, we have a potential difference of 1.3 by 10 to the 8 volts, and we know that the change in potential energy is Q times V. Now it's losing potential going from the ground to the cloud. So going to the more positive side, the higher potential, which is what the field is making it do. So it's losing potential, the amount it's losing is 1.602 by 10 to the minus 19, so that's the charge, times the potential. And that, if we choose to do it in joules, it is minus 2.08 by 10 to the minus 11 joules, or we could choose to keep it in electron volts, which would be just 1 times that voltage. So 1.3 by 10 to the 8 electron volts, still minus of course. And question 6, the kinetic energy gained is the potential energy lost, which is Q times V. And since we're interested in electron volts, it is 4 electrons worth of charge times V, and that makes it 24 EV.